Hi everyone, good evening. Welcome to the Marian Minor Cook Athenaeum. My name is Rukmini Banerjee and I'm one of your 3 Athenaeum Fellows for the year. Every day we are constantly barraged with information about climate change. Many people feel as if it is confusing and complex to parse through. We know that climate change is real and we know that it is a scientific fact. But for some, it's hard to understand exactly what those facts are and what the evidence is saying. To talk us through his interpretation of some of these numbers, we have with us today Professor Steven E. Koonin. Professor Koonin is a professor at the New York University. He has appointments in the Stern School of Business, the Tandon School of Engineering, and the Department of Physics. He is also the founding director of NYU's Center for Urban Science in Progress. The center works with academic, corporate, and government partners to demonstrate and develop informatics technology for urban problems in the living laboratory of New York City. Professor Koonin led the center from 2012 to 2018. Prior to his appointment, Professor Koonin served as the second Undersecretary for Science at the U.S. Department of Energy from May 2009 to November 2011. In that role, he oversaw technical activities across the department's science, energy, and security efforts and led the department's first quadrennial technology review for energy. Before joining the government, Professor Koonin spent 5 years as the chief scientist for BP plc, where he played a central role in establishing the Energy Biosciences Institute. Previously, Professor Koonin was also a professor of theoretical physics at the California Institute of Technology from 1975 to 2006, and was the institute's provost for almost a decade. He is a member of the U.S. National Academy of Sciences and the Jason Advisory Group. Today, Professor Koonin will tell us more about his findings in his recent book, Unsettled, What Climate Science Tells Us and What It Doesn't and Why It Matters. The book was published in 2021. In the book, Professor Koonin advocates for a more accurate, complete, and transparent public representation of climate and energy matters. Today's Athenaeum program will be different. The talk will occur first, and then the dinner, where select students will facilitate conversation while we eat. Afterwards, the Q&A will occur. The idea of the flipped app is an open academy principle that hopes to reinforce the principles of constructive dialogue in the context of exploring different views and perspective. During the small group dinner discussions, we hope you think about what are other perspectives on climate science. What is the potential social and economic impact of these different perspectives? Because dinner will be served at the conclusion of the talk, everyone should return to the seat at which they are seated at to start the discussion. Before we get started, a few quick reminders. Please take this time to silence and put away your cell phones. We have a very interesting lecture for you today. Be present and get ready to engage in dialogue and ask thoughtful questions. As usual, video and audio recording by the audience is strictly prohibited. Thank you so much.
Okay, it is great to be here. This talk has been 18 months in the making, just given scheduling issues. It's also great to just be back in Southern California and at a set of colleges that I knew well by reputation from my days in Pasadena. So my title tonight is really a triple entendre. It refers to parts of climate science, important parts that remain unsettled. It refers to how I felt, and perhaps you will feel, as I tell you some of the things that are actually in the science. And it also refers to what are we going to do about this important intersection between climate and energy. If I could paraphrase a lot of the popular and political discussion, it's that climate science compels us to make large and rapid reductions in greenhouse gas emissions. And it's good to, by the way, this will be a very data-driven talk, and all of the data and conclusions I'll show you come from official sources, so I'm not making any of this up. This is greenhouse gas emissions from 1970 up to 2020 for the globe as a whole, and the main lesson to take away is that this curve is going up and up as the world uses more and more energy derived from fossil fuels. And what large and rapid reductions mean, at least in UN language, is that we need to drive that curve on the left down to 0 by 2050 if we want to hold the global temperature rise to 1.5 degrees above pre-industrial, or to 0 by the end of the century if we want to hold the rise to 2 degrees, as shown on the right, representative trajectories. Well, you know, doing that will entail a major shift in society, as I'll get into. But whatever we do, they have to strike a balance. On the one side, we have the certainties and uncertainties of climate science, the hazards and risks and benefits, actually, as you will see, of a changing climate. On the other side, we've got the world's growing demand for affordable, reliable, and clean energy. And in the middle, as we weigh these two, frankly, contradictory factors, we've got to impose values and priorities, our tolerance for risk, equities between generations and between the northern and southern hemispheres, and the efficacies and costs of whatever it is we decide to do. Would it really make a difference? And so one is led to ask the question, are large and rapid reductions in emissions warranted? Are they desirable? And are they even possible? Let's start a little bit about the desirability, or the driver. How serious is the threat? Here is the global temperature record. It is some average of the temperature over the globe. And what you can see is that since 1900 up until the present, the globe has warmed about 1.3 degrees centigrade, Celsius. There is no dispute about that. The globe is getting warmer. It's been getting warmer since the 1700s as we came out of the little ice age. 1.3 degrees in about the last 120 years. If you listen to the UN and read the reports, a comparable warming, another 1.3 or 1.4 degrees, is expected over the next 80 or 100 years. And the question everybody is concerned with is what will be the impacts of that warming, both on ecosystems and on societies. That's a highly unsettled issue, but we can get some guidance by looking back to 1900. And what you discover is that humanity has prospered since 1900, even as the globe warmed by 1.3 degrees. The population grew by a factor of 5. There are 5 times more people on the globe now than there were in 1900. The life expectancy went from 32 years to 72 years today globally. The fraction of people who are literate went up by a factor of 4. The GDP per capita went up by a factor of 7. You can go on. And maybe most relevant to the climate discussion, the death rate from extreme weather events went down by a factor of 50. It is hard to believe that another 1.3 degrees of warming is going to significantly retard or even reverse this kind of progress. Some people say we have broken the weather already and we're seeing the effects of climate change. Well, maybe, but if you look at the data on economic impacts, that's not so obvious. This is the rate of weather-related losses as a percent of GDP for the globe over the last 30 years. And what you can see is that the vertical scale is in tenths of a percent per year. There are big fluctuations from year to year, again, but the overall trend is downward. And so we're actually losing less economic activity to extreme weather than we were 30 years ago. If you read the IPCC reports, not the summaries for policymakers, which are a pale reflection of what's actually in the reports, what you find is that it is tough to detect or attribute most extreme weather events showing a trend. And here are some direct quotes. There's low confidence in long-term trends in tropical cyclones, hurricanes, frequency or intensity. Low confidence in mid-latitude storms. Trends in tornadoes, hails, lightning are not really robustly detected. You can go on and on. There are some trends that we see. For example, precipitation over most of the land has gotten lumpier. And of course, as temperatures go up, the incidence of higher temperatures has gone up as well. Nevertheless, we are bombarded in the media with phenomena that are purported to due to climate change that portend disaster. One of my favorites here is about Greenland losing ice. And here's the headline from The Guardian, which is a paper in the UK a couple years ago, also a NASA press release in March. Greenland's ice sheet is melting 7 times faster than it was in the 1990s. They've got this great picture, and then the text says glaciers, the rate of ice loss has risen from 33 billion tons a year in the 90s to 254 billion tons a year in the past decade. Wow, it sounds like it's getting worse and worse. This contributes to sea level rise as the ice melts and so on. Well, you know, as a scientist, I've learned not to trust anything in the media, but to go back to the data or the scientific reports. And so I did, and I actually published in the Wall Street Journal just about a year ago the data. Not my data, the official data from the Danish Meteorological Institute. And this is the amount of ice that Greenland loses every year, averaged over 10 years. And sure enough, if you go from 1990 up to the mid-teens, it went up a lot. But looking at this, you say, it also went up in 1920 a lot. And in 1930, it was almost losing as much ice every year as it was recently. And in fact, it's been going down for the last couple years, even as human influences grew steadily during this century. So this has got very little, if anything, to do with global warming. In fact, it's got to do with variations in the North Atlantic. Nevertheless, the newspaper, if you didn't know anything, you read the newspaper, you'd say, oh my God. Right? So digging a little bit deeper is really important. Economic impact. All right. Here is the IPCC writing about 7 or 8 years ago, direct quote out of one of their reports. For most economic sectors, the impact of climate change will be small relative to the impacts of other drivers. Changes in population, age, income, technology, lifestyle will have an impact that is much larger than climate change. Here's a recent review paper. It shows if the globe were to warm by 4.3 degrees. Remember, the UN is talking about 2 degrees or less in 2100. How much of a hit will you have on the global economy? And leaving apart all of the detail, what you can see is that the vertical scale is measured in percent. That means that the economy in 2100 would be a few percent smaller than it might have been otherwise if this warming happened. You don't hear that in the papers. I'm not going to go through that detail. All right, so let's now turn to the question. That gives a little bit of sense of just how strong the justification is for large and rapid reductions. Let's talk about whether they're desirable or not. And in order to do that, I want to take a look at global demographics and development. This is the global population, both historically and then projected out to mid-century. And what you can see is that we just crossed 8 billion people this last year, and this projection says we'll get to a bit more than 9 billion people by the middle of the century. As you can see, most of that growth is in Asia. In the OECD countries, North America and Europe, population is very slowly growing, if at all. As people develop economically, they use more energy. This graph is one of my favorite graphs in the subject, and what it shows is the annual energy consumed per person per year, plotted against the GDP per capita per year for different countries, the US going on down the list. And what you can see is that there are some countries like the US and Canada up here that use a lot of energy per capita, but also have a pretty high income. There's a whole other swath of countries down here in the middle, including the EU, Japan, that have slightly lower energy consumption, but comparable standards of living. And then what is sobering, though, is that there are only about 1.5 billion people in the upper parts of this graph. The other 6.5 billion people are down here somewhere. And you can be sure that their energy use is going to grow as they develop. The inequalities are astounding when you look at them. This is what energy poverty looks like when you're doing your cooking or heating. What's called traditional biomass, wood and dung, being burned for cooking and heating. The indoor air pollution kills 2 million people a year. Dining by candlelight is romantic, but not studying by candlelight. And if you don't have energy, modern electricity, this is what you do. Quantitatively, the US per capita energy consumption is 30 times that of Nigeria. And there are 3 billion people in the world who use less electricity every year than the average US refrigerator. We should hope that these folks develop, that they get more energy to do that. Well, when you combine the demographics and the development, you can see that global energy consumption is going to go up by about 50% over the next 30 years. Most of that growth, again, coming from Asia and a bit from Africa. If you take current policies, no changes in government policies, that additional energy is going to come largely from fossil fuels. Yes, renewables will grow, wind and solar, but in fact it's going to be coal, oil, and gas unless something unexpected happens. Fossil fuels have supplied about 80% of the world's energy for the last 30 years. You can see here, fossil fuel line over here, again, about 30 years. Coal, oil, and gas over here, a little bit of nuclear, wind and solar down over there. Yes, they're growing rapidly, those renewables, but they're still a small fraction of the world's total. And as those countries grow, the fossil fuels are the most reliable and convenient way for them to get their energy. Here is what the EIA, the U.S. Energy Information Agency, projects is going to happen to emissions out to 2050. Here we are today. This is historical data. The OECD, the developed world, 30-some-odd countries in the developed world, emissions will be flat, if not slightly declining, whereas the non-OECD countries, the developing world, will see a strong growth in their emissions. And remember, you got to drive this curve to zero if you want to stabilize human influences and allegedly stop the temperature from increasing. One of my favorite social scientists, I don't have many favorite social scientists, but Anthony Downs is one I've been reading quite a bit, and a very interesting guy. He was working at UCLA in the 60s, and he was watching the smog in the basin get worse and worse as more and more people acquired automobiles. And he wrote this really interesting paper in 1972 in which he said, the elite's environmental deterioration is often the common man's improved standard of living. Okay? And so when people say the science compels us to make rapid reductions, the appropriate response from the developing world is, what do you mean us? So here's the Indian Prime Minister, Modi, a year ago saying, the colonial mindset hasn't gone. We are seeing from developed nations that the path that made them develop is being closed to developing nations. And then the Nigerian president said Africa is being punished by the decisions of Western countries to end public financing for foreign fossil fuel projects by the end of 2022. We are going to continue to fight. We have fossil fuels that should be exploited. So I think a central question that should be asked of anybody who advocates for rapid reductions in global emissions is, what are you telling the third world? Another dimension of the morality of rapid reductions is that, at least in the West, I think we have robbed your generation of optimism. Here are people demonstrating in London that believe that the Earth is going to be uninhabitable in a decade or so. And I always wanted to put a picture of Miley Cyrus in one of my talks. I found the appropriate quote. She said a couple of years ago, "We're getting handed a piece of shit planet, and I refuse to hand that down to my child. Until I feel like my kid would live on an Earth with fish in the water, I'm not going to bring another person to deal with that." Okay? Entirely unjustified pessimism and just not very healthy mentally. And I think a third question one needs to ask is, can we make large and rapid reductions? I think one of the things to understand is that energy is provided by a system, whether it's fuel for vehicles or electricity, and those systems evolve only over decades. This shows sources of U.S. energy for over almost 70 years. And what you can see is that the shifts in how the country gets its energy evolve only over decades. We started with wood, and then we got coal, and then we got oil and gas and so on. And interestingly, each new source piled on top of the other. It didn't displace it. Except in the last couple decades, natural gas has been displacing coal, and renewables are starting to displace coal as well in electricity generation. So you don't want to change energy systems very rapidly. They change slowly because the facilities last a long time, power plants last 50 years, and the system needs to be highly reliable. So you don't tinker with it without thinking it through. So the world is headed, or at least the developed world is headed, to this all-renewable, all-electric world. And like Wile E. Coyote here, we have realized that there are some fundamentals that are not going to spell a good outcome for this. And let me take you through some of those. The electrical grid is central to plans to decarbonize the US and Europe. We would like our electricity to be clean, no local pollution, but in this context, no CO2 emissions as well. We would like it to be affordable, and we would like our electricity to be reliable. That triangle is very difficult to satisfy. If you want to be affordable and reliable, we have coal, we have gas, not very friendly in terms of CO2 emissions. If you want to be affordable and clean, you got wind and solar, but terribly unreliable, as I will show you in a moment. And if you want to be clean and reliable, you've got nuclear power, carbon capture, and storage. We do not know currently how to square this triangle, so to speak. If you want to build a grid with wind and solar only, which seems to be the current fashion, the most expensive part is reliability, as I'm about to show you. So again, real data. This is the amount of electricity, or the fraction of electricity, generated by wind in the UK for 6 months that span the end of 2020 to 2021. And what should impress you is the variability of this, due entirely to the weather, the wind patterns that afflict the UK. And what you can see is that there are sometimes long periods, 11 days, in which the wind doesn't produce much electricity at all. This is a pretty common phenomenon. It happens in Texas. It happens in Germany. The Germans gave a name to it. It's called Dunkelflaute in German. You'll forgive my pronunciation. And what that means is dark stillness. So neither the wind is producing electricity, nor is the solar. And those periods are pretty significant. And what that means is that you had better have a backup system that's at least as capable as the wind. And therefore, electricity is going to be at least twice as expensive as what you thought it would be for just wind and solar. Here's a study that was done by my good friend Nate Lewis, who's a professor at Caltech, and Ken Caldera, who's a professor up at, or was a professor up at Stanford. How much does electricity cost in the US if you want to be reliable at 99.99%? That means the electricity should be there except for 1 day out of a decade. That's the current US standard. And you can see natural gas with carbon capture and storage, natural gas with solar and wind, you're down about a tenth of a dollar or 10 cents a kilowatt hour. If you want to run with nuclear, costs go up a little bit, but if you want to run wind only or wind and solar, the costs are significantly greater. Okay? So anybody who tells you that renewables will be cheap is just not paying attention to the data. Wind and solar also have issues with how much land they use. They're diffuse energy sources, so you need a lot of land to capture enough of it. This shows how much land gets used by various ways of producing electricity. You just look, wind uses 72 square kilometers per terawatt hour per year. You get down to some of these other technologies, it's much less. Another problem that has gotten a lot of attention recently is that these modern technologies use a lot more fancy materials than do the conventional energy technologies. So for example, an electric car compared to a conventional car uses about 7 times more fancy stuff. Copper, lithium, nickel, manganese, cobalt, graphite than does a conventional car. For power generation electricity, wind uses about 9 times more fancy stuff than does natural gas. And the question is, can the world provide enough of these exotic materials in order to scale up the technologies at the pace that many people envision? Even worse, currently, a lot of that material comes from not very friendly places. A lot of, somebody's just written a book about cobalt. You can see that 60 or 70% of the world's cobalt comes from the Democratic Republic of the Congo. Not a very friendly place in terms of human rights or environmental friendliness. Similarly, a lot of the processing of the rare earths of nickel, cobalt, lithium, so on, comes from China. Not so good either for the US. Okay, let me close with some specifics about energy. It's kind of hard to make predictions, but you can see some broad trends of what I think will happen. Coal use is going to rise. It's already rising. India, I think, is projecting 8% rise in coal next year. Okay? They need the electricity. Eventually, it will decline as the developing world moves on and other sources become more economic. Natural gas, we're going to see more and more natural gas, both in the developed world and the developing world. What's not to like? It's clean, no particulates. It's got half the greenhouse gas emissions of coal per unit energy. And in some countries, like the US, it's abundant. Even Europe has 100 years worth of natural gas in the ground if they chose to get it out. Hydrogen, another current fad. I think it's unlikely for passenger cars. There are just too many problems with it technically. You might see it for heavy transportation, and it might be possible as a way to store energy for the grid when you have wind and solar producing, and then using it at night or when the wind is calm. We're going to see in growing electrification. It's already underway for light-duty vehicles, for passenger cars, but you worry about the grid capability. Can you provide all that electricity and all that power? The charging infrastructure and critical materials, again, as I mentioned. For building heat, we're going to see heat pumps in temperate climate, but I can tell you it's got drawbacks. So this past week, I was up in Palo Alto at Stanford and staying in an apartment near campus that was all electric. Okay? So heat pumps in the rooms, induction stove, induction cooktop, electric stove, and so on. And unfortunately, Tuesday afternoon, we had terrible winds, knocked out the electricity for large areas of Palo Alto, Menlo Park, and in general, the peninsula. And I can tell you, I had no heat, I had no light in this all-electric modern apartment, whereas places I live in the East Coast, you at least had natural gas for heating and cooking. So, you know, relying on a single source, namely the grid, for everything is not necessarily a very resilient alternative. Wind and solar are going to grow, but we're going to have that backup. Nuclear power, fission, I think will be an important part of the grid if we really want to go to zero emissions. I can say something about fusion in the questions if people are interested. Supply chains, also, critical materials. The U.S., through the Inflation Reduction Act, is starting to try to bring supply chains back domestically, or at least to friendly countries. We're going to see a lot of recycling also, batteries and other material. All right. You know, if you ask me what do I think the world is going to do rather than what it should do, I think the dominant response to a changing climate is going to be adaptation. Adaptation is agnostic, which is good. It doesn't matter whether the climate is changing for human causes or natural causes. It's proportional. If the climate changes a little, you adapt a little. If it changes a lot, you adapt a lot. It's local. Adaptation is a local phenomena. It doesn't require global action, which we're having a very difficult time getting. And it's a lot easier to sell politically when it's here and now for people. It's also autonomous. It's what society does, maybe one of the defining characteristics of humans. And it's effective. As I showed you, as the world has managed 1.3 degrees over the last 120 years, and people live everywhere from Hudson Bay down to the equator. We change society appropriately to manage. All right, a couple of final thoughts, and then we can get on to dinner. One of the reasons I started speaking out already about 6 or 7 years ago is we must not Gruberize climate science or energy. What do I mean by Gruberize? Well, Jonathan Gruber is still a professor of economics at MIT. He was one of the principal architects of the Affordable Care Act when he was working with the government back about a decade ago. And Professor Gruber, at one point after the Affordable Care Act was passed, said at a conference, lack of transparency is a huge political advantage. It was really, really critical to getting the Affordable Care Act passed, Obamacare. At least one key provision was a very clever basic exploitation of the lack of economic understanding of the American voter. Now, whatever you think about the Affordable Care Act, and I actually think it's a good thing, for an academic to say this and to believe this is just so wrong. And I would assert that the same thing is going on with climate and energy right now. When you misrepresent things in order to persuade people rather than to inform them, you take away the right of the public to make fully informed decisions. You distract from more urgent needs, and boy, do we have many of them. You tarnish scientific inputs to other important policy matters, like pandemics. And you depress young people, and that's really why I decided to speak out and publish the book just about 2 years ago. All right, that's enough of throwing tomatoes at everybody. What do I think we should do? All right. First thing is we got to cancel the climate crisis. This is not a crisis. We have the time to deal with it, acknowledge that there is a task and a challenge here. I think we need better representations of this situation to non-experts, and we need to improve climate and energy literacy. You know, I teach at NYU still at the master's level climate in the fall and energy now, do weekly lectures, and what I find is that the students' eyes are opened up in both classes, both about what the climate science really says and what the possibilities are for changing the energy system. We need to keep studying the climate. You know, climate is a 30-year average. We have not very good data going back about 100 years. We need to do a better job of that. I think we must not constrain the developing world's energy supply. Right now, they need the energy, and fossil fuels are the best way for them to get that. You know, telling them that they can't emit is like telling a starving person, you got to worry about your cholesterol. There are more immediate needs that they have, and it's immoral not to let them do that. I think we need a greater focus on adaptation. There's no framework yet, no estimate of costs, and we need to promote the resilience of developing countries in order to adapt. Technology, or more generally innovation, is going to be really important to reducing emissions. I think now, today, fission, storing electricity for the grid, managing the grid, batteries, non-carbon chemical fuels are all things that I would be pushing hard on doing research demonstration on. And then lastly, you know, energy touches just about everything in society. It's complicated. Nobody has written down graceful decarbonization strategies that respect technology development, economics, regulation, and behavior. That's a task that needs to be done if we're going to tackle this problem at all. And with that, thanks for your attention, and I hope I've stimulated some good dinner table conversation, and we'll look forward to comments and questions over dessert. Thank you.
We're going to transition to the Q&A portion of the evening. So what we're going to do is that we're going to ask each of you to line up at these two mics. We're going to be alternating between the two. Come up and ask your question to the speaker, and when you do, please make sure to introduce yourself, say your name, your year, as well as your major, and the school you're from. And please only ask one question at a time, and then keep it brief. Thank you so much.
Hi. So I have a question. Well, first of all, let me say that I definitely agree with a lot of the facts that you presented in the second part of your talk about just how difficult and complicated and in some ways seemingly impossible it is to combat climate change. I think definitely I strongly disagree about your means, and the thing I disagree with most is it just seems that your means are to not do anything. And so I'm stealing this metaphor from my friend Ryan, who I don't think is here, but I guess I'm just wondering what you think about this metaphor. You know, if you have a rock and you've had this rock for your whole life and it's helped you through so many things, and it got you a great job, and it got you a great relationship, and you have a whole bunch of money, and you attribute it all to this rock, and then one day you learn that it's actually a hand grenade. Like, why would you keep the rock? So I'm curious your opinion on that.
Okay, let me correct a misperception first. I mean, that's what I was saying, all right? I don't think there's do nothing there, but I think it's do things that are effective and do things that aren't worse than the climate change itself, okay? So do things thoughtfully, do things at an appropriate pace, all right? The story about the rock, the problem is you're still going to need something that the rock does for you. And
I just have to restate, the rock is a hand grenade.
Yeah, okay. But the rock is giving you a lot of benefit and continues to give a lot of benefit, right? So you're going to replace it with something that isn't going to blow up, right? The problem is we do not have, in various dimensions, good replacements. The dimensions are economics, reliability, scalability, and so on.
So you would maintain your position that you should keep the hand grenade?
No, I think that's a silly analogy, right? Okay? because we're not facing an existential threat. It's not a hand grenade, okay? At least according to the IPCC.
All right, thank you.
Okay.
All right, cool. Hi. Oh, wait, is this?
Yeah.
Is it working?
Yep.
Okay, cool. Weird, I couldn't hear it. Huh? Oh, that works. All right. Nice to meet you. Thank you so much for your talk. It was really interesting. I'm Rowan. I'm a first year here. So my question is about. I know you spent like forever in climate science, so you're probably super familiar with like the planetary boundaries model, because it's a big deal nowadays, and people should Google it because it's cool. But one thing that's really interesting, I think, in that model is how it points out so many different crises, or not crises, but like problems that we're dealing with aside from like carbon emissions. So stuff like the disruptions to the nitrogen cycle, and like problems with biodiversity, and like things with the phosphorus cycle that are getting messed up, and like emissions of all sorts of other various chemicals that we're putting out into the world that we kind of don't know what they're doing. So if you could like touch on what you think the scale of those problems is, like how immediate, how pressing do you think they are, and then like what should we do about them?
Yeah. You raise a very good point, that there are a host of problems. Some of them are more urgent than others, and some of them have a greater benefit to cost ratio. And there is a guy, I just heard him talk at Stanford last week, named Bjorn Lomborg, who started already 20 years ago seriously asking about benefit cost ratios for many different things. And it's worth looking at his research. There are papers he's written a couple books. And it turns out, if you try to do a sensible analysis, climate itself is not a particularly cost-effective thing to be dealing with. There are many more urgent problems, public health being most obvious, literacy, energy, and so on, that when you try to do a rigorous, however imprecise, rigorous analysis, are much better ways to be spending the world's resources right now. Doesn't say that, and he wouldn't say that the climate is not an issue and is something we need to deal with, but when you make a priority list, as he does, and other people have done similarly, it doesn't come up real high.
All right, cool, thank you.
All right. Lomborg, L-O-M-B-O-R-G. First name is Bjorn, B-J-O-R-N. Okay.
Hi, my name is Simran. I'm a junior studying economics and data science. Thank you for your talk. I really enjoyed all the graphs that you provided. And my question is about the developing world and how, some people think that they shouldn't use fossil fuels, and then some people, like the Nigerian president, think they should because developed countries use them. So I'm wondering how you think overpopulation factors into it, since a lot of these developing countries' populations are just exploding and they don't have the resources to support all the people.
Let me put up my graph again. Let me see if I can find that. So, no, I want to, sorry, go to this one. So you look at global energy, right? And it's going up, and it's really going up for two reasons. One is the population goes up. But, if we go from 8 billion to 9 billion, that's a 12% increase in the population. But you see the energy goes up by 50%. So the dominant driver of energy is development, not so much population. Yeah, there are problems in individual countries, I'm sure, but overall, it is the development that is going to make a problem for us, and not so much the population. Okay? And you can see that quantitative. I actually show a chart in my class. You look at the decade by decade increases, population goes up, not very much, but the energy use goes up a lot.
Okay, thank you.
Right? Good.
Hi, thank you very much again for your talk. I'm Dean. I'm a senior at Pomona. We talked a little bit before.
Yeah.
I think that was like great analysis to center the economy at the at the heart of your talk.
I'm sorry, say again?
To center the economy at the heart of your talk, to say that, you know, humans will be fine. Obviously, you know, a dip in the economy does affect human lives, but taking a slightly different stance, we're going through like a mass extinction event right now, and relying on the economy or relying on human adaptation to save humans is one thing, but relying on economic incentives and, like, you know, the invisible hand of the market to save, you know, animal lives might not necessarily work out. So I was wondering, like, just generally,
What I think
what's your
about that.
Yeah.
Well, you know, I like animals as much as the next person, of course. The problem is, you know, if you're faced with a choice, one or the other, how do you strike that balance, right? And I think, you know, the humans win, hands down, okay? At least for us as a species. That doesn't mean you want to see the whale population decimated, to take a current example. But you need to tend to humans first. I think it's a Western ethos, right? Okay. You're going to tell people in, I don't know where, Bangladesh, that you can't have refrigeration as abundantly and as cheaply as people in the West, because we need to save sea lions or something. That doesn't work. Okay? That doesn't work.
Thank you.
All right.
Hi, I'm Anna. Thank you so much for your talk. I really enjoyed it. My question has to do with the dynamic effects of renewable costs. I think especially solar over the past several decades, we've seen some pretty impressive cost reductions. And I'm just wondering if you think that'll kind of affect, and sorry, I also want to add that we get more efficient, for example, at using some of the minerals and et cetera that you were mentioning. And so I'm wondering if you think that might complicate your prognosis. I did note that you noted batteries as a aspect of to focus development on. But
there's several different issues there. Let me try first. Solar costs have come down, all right? And right now, the most expensive part of a utility scale solar array is not the modules themselves, but it's the frames and all of the what's called balance of system that you have to put in. It's more than half the cost right now. So you got to work on those more conventional things, like paying people to go up on the roofs if it's residential, or aluminum frames, or tracking systems, and so on. You can have too much of a good thing. As you probably know, in California, solar is overbuilt, and the utilities are cutting back on the incentives, because solar produces during the day, and you can only take so much of it. It doesn't produce at night, so you got to put in storage. That's got its own issues, and you can try to incentivize that. So again, it's a system issue, and trying to just put one technology is not going to result in a balanced outcome. I forgot, there was another part of your question.
Just about increasing efficiency in the kinds of minerals we use to produce batteries.
Oh, yeah, right. So the minerals issue was a real one. I said at the table, and I'll repeat for everybody. We're projecting about a 30% shortfall in copper demand 10 years from now, because you need copper to make batteries and other things. The world only has a limited amount of primo copper ore, and if you want to go to lower grade ores, it takes 15 years to start a copper mine. All right? So nobody's thought about this. Well, people have, but for people in their enthusiasm to deploy the new technologies, it was like one of those Wile E. Coyote moments. Oh, that's a problem. Right? So I think for the critical minerals, you can try to use them more efficiently. You can recycle, although if the demand is growing, the recycling doesn't help too much. And then you can look for alternatives, substitution. People are trying to do all of that. So it's an issue.
Thank you.
All right. Okay.
Hello, my name's Johannes Brown. I'm a first year here at CMC.
I'm sorry, I didn't catch your name.
Hello, my name's Johannes Brown. I'm a first year here at CMC. Okay. Can you go to slide 31 really quickly?
31?
Yeah, 31, I think. The one with your book on it.
Oh, yeah, right.
Yeah.
Let me find out. There it is. That one?
Yeah, that one right there.
Okay, good. Let's see. Oh, doesn't have the best mouse.
Totally fine.
All right, there we go. Yeah.
I think this slide right here is something that like I really like took away with that line about the lack of transparency, and then how this whole presentation is really like trying to be transparent with people and like give them information that like other people don't usually see. And I think in some ways this almost detracts from our understanding of climate change. And I think the United States government as a whole and companies that deal with fossil fuels need to be more transparent with the people about the real issues that are going on. And I really want to ask you about the ways in which you feel, or I think I know what I know what I feel, but what you feel about the ways in which companies, fossil fuel companies in specific, have been detracting against research into climate change. Like, it doesn't make sense for a company to research their own demise. So in what ways do you think these companies have led us, the American public, astray dealing with climate change?
I don't know anything about the Exxon situation, which is maybe the most famous, right? There are people who claim Exxon knew, right? So I don't know anything about that other than what I read in the papers. I do know when I was in BP, John Brown, who was the CEO at the time, was one of the first fossil fuel companies to stand up and say, we need to deal with reducing emissions. And that's one of the reasons I was hired, not to help them find oil, but in fact to figure out alternative and renewable energy technologies. That said, you may have read in the papers last week, BP is scaling back on its renewable investments because you can't make any money at them. Right? And that's true generally. So there are people in fossil fuel companies who are unabashedly saying, and I more or less agree with them, we provide a valuable product for consumers. We're not going to make any apologies for it. Chris Wright is a guy to look up, W-R-I-G-H-T. He's the CEO of something called Liberty Energy, and he wrote a remarkable environmental statement a year or two ago that's worth reading. Okay.
Thank you.
I can tell one story about Chris, which is good. I think it was one of the outdoor companies, REI or Patagonia or something, who was pushing, we've got to get off of fossil fuels. We're going to divest ourselves from fossil fuels. And Chris Wright, he actually wrote a public letter and said, where do you think the material from which you make your products comes from? All the polymers and nylon and so on. That made them a little bit embarrassed, I think. Okay. Yeah.
Hi, my name is Alessia. I'm a senior here at CMC. I'm a biology major. I have a clarifying question for you.
Please.
So, in my understanding, you believe that climate change is happening, but that it shouldn't be cause for alarm and that it's not a crisis. I am curious if you could define what would make climate change a crisis. I know the World Health Organization and many other scientific journals have predicted hundreds of thousands of deaths by 2050. I know it's pretty hard to predict the exact amount of harm that's going to happen, but just going off that number, do you consider that number of deaths a crisis? And if not, how many people would have to die for climate change to be a crisis? Or are there other measures you're going off saying that we shouldn't be alarmed by this?
Yeah. Well, let's talk about deaths. Shall we do that?
Sure.
Okay. Here's one. Temperature-related deaths, right? This is from a study in The Lancet, a pretty reputable journal, medical journal. We found, this paper says, we found 5 million deaths per year associated with non-optimal temperatures, accounting for 9.4% of global deaths and equating to 74 temperature-related deaths per 100,000. Most excess deaths were linked to cold temperatures, whereas fewer were linked to hot temperatures by about a factor of 10. The global mean daily temperature increased by 0.26 degrees per decade during the early part of the 21st century, paralleled with a large decrease of cold-related deaths and a moderate increase in heat-related deaths. Okay?
What year is this for?
This is, well, I think this was for 20 years in the first 20 years of this century.
Oh, I was talking about in the future,
Oh,
like by 2050,
all right.
for
So
example.
I don't know if I have the chart here. Michael Greenstone, economist at Chicago, led a large team that did a study of temperature-related deaths. For a moderate emissions scenario, which is more or less what the IPCC expects now, somewhere between RCP, if you know the language, RCP 4.5 and 6,
Yeah.
the amount of excess deaths are consistent with 0. There's a big uncertainty, of course, but it goes both plus and minus. Okay. You take an extreme scenario, RCP 8, then you get more deaths than more than 0. All right, I think I have the graph somewhere. If you write me an email, I will send you a reference to the paper and some of the charts. Okay.
Okay.
All right.
I guess could you follow up on the second part of my question?
Which was?
What would make climate change a crisis to you? Like what data, I guess, would have to...
Sea level rising at a centimeter a year. It's currently 3 millimeters. Okay. What else? Temperature going up at half a degree a decade. Okay. Greenland really starting to melt as opposed to the ups and downs. Okay. Don't see it. There's no long-term trend in hurricanes. Okay. No long-term trend in mid-latitude storms. The droughts that we see in California are not very much different, as far as we can tell, from what we've seen 500 or 1,000 years ago. So I would say something really out of line of the historical record.
Okay, thank you.
Okay.
Hi, I'm Gabriel. I'm a senior at Pomona. I was going to ask a different question, but I'll follow up on that one. Could we go to your sea level slide towards the beginning with the graph in Greenland?
Oh, do you want it the Greenland or a sea level graph?
The one you showed in your presentation.
Oh, the Greenland slide. Yeah. Let me see if I can find that. There we go. Yep.
So regardless of what's happening on that graph, and it does actually look to me like there is a long-term positive trend on there if you put a line of best fit on there. The IPCC concludes that there's medium confidence that with 2 degrees of warming, sea level will rise between 0.3 and 1 meters by 2100. And it has high confidence that the sea level will continue to rise well after that. So do you either disagree with this finding, not think it's a huge problem, or you do think it's a problem, but it's outweighed by the negatives of avoiding it?
If you're okay with it, I want to go through 3 charts about sea level rise.
Sure.
And which is a little bit different than Greenland melting, all right? Okay. So let's start with historical context, all right? That's sea level, as near as we can tell, starting when the last great glaciers started to melt 20-some-odd thousand years ago, okay? And you see it's gone up by 120 meters, 400 feet, okay? It went up pretty rapidly over here, and then much less rapidly starting about 8,000 years ago. So the issue is not whether sea level is rising. It's been doing that for 20,000 years, having nothing to do with human influences. The real question is whether it's accelerating or not, all right, due to human influences. Good. So let's go to the next chart. Right. This is the rate of sea level rise in millimeters per year from a recent paper cited by the IPCC, all right? And what you see, it goes up and down. Right? A lot of natural variability. And you can get excited about the fact that it's going up for the last 2 decades, but it was going up before, or the rate, so it was accelerating. I live in New York City, all right? This is not global sea level, but this is sea level as measured at the Battery, the southern tip of Manhattan. There's been a tide gauge measuring there for 160 years. Okay? This is the 30-year, the 30-year rate in millimeters a year. Surprisingly, it goes up and down like that, averaging about 3 millimeters a year over the last century. That's a foot a century. Manhattan has done just fine under that. If you look at what a NOAA report in February said is locked in, going to happen no matter what, is that that graph is going to go up to where the red star is. All right? We'll know soon enough whether that's true or not. Okay?
So are you disagreeing with NOAA's conclusion that that's likely?
I would say I'd bet my house that that's not going to happen.
And you're disagreeing with IPCC's conclusion that it's likely to see between 0.3 and 1 meters by 2100.
So 0.3, that's a pretty big range, 0.3 to 1, right?
Yes, but
Okay. So 0.3 is consistent with the 3 millimeters a year. That the sea level is going to go up, that it might go up a little faster, fine. I won't disagree with that, but it's not obvious, right?
I don't know if it's obvious. I just know that the conclusion by the IPCC is that it's got medium confidence of happening.
So what I would say is, IPCC, if you can explain that, the historical data, with variations of the scale that you're predicting, then I'll start to believe you. And they can't.
Thank you.
Okay?
Hi, Professor Koonin. My name is Jeannie Kim, and I'm a senior at Claremont McKenna studying environment, economics, and politics. Coming from a quote-unquote developing country myself, I think your presentation did not really address the fact that, I know you mentioned the case of Nigeria, but some developing countries are actually very excited about renewable energy and, have taken a lot of projects, and they have also created their goals to, become carbon neutral or whatever term you want to decide to use. And I'm wondering what your thoughts are on that, because, developing countries have their agency too, and if you're going by that Modi quote that you used, we shouldn't be imposing these models on them, but at the same time, this also imposes that they are only going to use, fossil fuel energy. And I would love to pick your brain on your thoughts on developing countries actively choosing to use renewable energy.
Think if a country decides to go that way, more power to them. I think the problem I have is that when we sit in our rather comfortable surroundings and tell them how to make choices, that's where I have a problem.
Okay, and if I could ask a quick follow-up question, the U.S. is considered a very developed country, but there are people within the United States who feel the effects of climate change very, very differently. And so what do you do about that, and your comment that maybe perhaps it's not the most urgent issue?
I think there are urgent issues in the U.S. associated with energy costs. You can read in the paper about people's electricity bills going up by factors of 3 or more, about gasoline prices. People are quite upset about. People cannot afford the capital investment to buy an EV right now. The government is handing out $7,500 incentives sometimes. So it's not just climate change that people are feeling the effects of. People also often confuse climate with weather. Okay? Most of the weather we're seeing is not unusual, not unprecedented. Right? The atmospheric rivers, the Bay Area got clobbered in 1861 by an atmospheric river much greater than anything we've seen subsequently. A lot of it is weather. Right? So we should respect zoning rules. People maybe shouldn't be living in Miami Beach because it's low, but it's been low all the time, et cetera. All right?
Okay, thank you so much.
I'm trying to find a graph. I can't find it. Sorry, go ahead.
Oh, hello. I'm Maya. I'm a freshman from Harvey Mudd, and thank you so much for your talk. There were a lot of things that I wouldn't have considered. I was just wondering, taking intro biology right now, a lot of the arguments that they seem to be telling us in class is that a lot of it is positive feedback loops in terms of there being more greenhouse gases. And so I think the worry is that we'll go beyond a point where everything will just keep accelerating. And I think also that you did a really good job of showing us that there are so many different graphs that show so many different things. And obviously, you know, I've seen a lot of graphs that show opposite things as well. And so I think a lot of it is that we really don't know. And I think that because it is something so important as, you know, the earth, and that a rise might end up being permanent and, you know, forever changing ecosystems and living conditions and things like that, basically the worry that it's irreversible. And so what do you think too in terms of like what we know versus what we don't know, in terms of...
We don't know how warm the globe's going to get, even for a given amount of emissions. We don't know how much it would cost to reduce the emissions. We don't know what the benefits would be if we reduce the emissions, because the climate keeps changing even without human influences, right? Somebody said, what about climate? We confuse climate change, which means human-induced, with a changing climate. The climate has changed forever, okay? And so when people say we're going to stop climate change, they should be very precise about what they say. So we don't know how the climate's going to change in the future. We don't know how much it's going to cost, and so we're supposed to spend N trillion on this when there are many more real, immediate, and soluble problems that we could be addressing.
I see. Thank you.
Okay? I want to put up. Next, please.
Oh, hello, my name's Aiden, and I'm a sophomore at Pitzer. And I was just curious, you mentioned a lot in your graphs, a lot of measuring of like GDP and GDP per capita. And I was just curious, like, should that be the way we like measure the like quality of like a nation, or for GDP per capita, the quality of a life for a person? Like, sometimes if I hear the two statistics, I don't really know that affects me. Should there be a different measurement we should use that's more comprehensive?
Yeah, so there are such other measurements, something called the Human Development Index, I think, that the UN promulgates, which has got, income does figure into that, but it's logarithmic rather than linear, okay? And maybe there should be a different measure, but I think as a general principle, people with more money are happier, right? And I think you see that. Nobody is voting to be poor, right? Particularly down in the lower part of that graph. I mean, those people, who would want to trade positions with those folks right now? Right? Okay. So yes, you could have a different measure on the margin, but I think the general trend that you want to be moving up that scale is unimpeachable. I want to show you this one graph before we go on. This is, I think, another powerful graph about confusing weather with climate. Did I answer your question okay, or do you want to?
Oh, thank you.
Okay, good. So in Egypt, there is a device that measures the height of the Nile River all the time. And that device, called the rotonilometer, has been in existence since 830 or 40 AD. And we've got pretty good records of the height of the Nile every year from, well, actually, I'm sorry, 640, the time of Muhammad, all the way up to about 1500, okay? So what this data shows is the minimum height of the Nile every year for the roughly 900 years. And there's lots to learn from this. One is there are big fluctuations from one year to the next. This one is down over here at less than 1 meter, and the year before it was up at 4.5 or something, right? So, large fluctuations. The second is that even when you take a 30-year average, climate is defined as the 30-year average of weather, you get this red curve, and remarkably, it goes up and down as well. There are long-term, it's what's called red noise, long-term fluctuations in the climate. And you can just imagine, as the river became drier and drier over that 100 years, there was some medieval Egyptian climate panel that was saying new normal, right? There are no human influences here at all. And then if you just wait another 100 years, it comes back again. So you can be fooled. Right? And when you ask the IPCC, do your models have this kind of long-term behavior in it? They say, we don't know. So that's why a little bit of caution in saying, oh my God, is warranted.
Okay, thank you. I'll try to make this fast since I know we're running out of time. Thank you so much for your talk tonight. I feel like one of the main conclusions of your presentation was that we need to cancel the climate crisis. And correct me if I'm wrong, but I feel like you had two main arguments here. One, the resources could be better spent in a different place. And two, we don't want to inhibit the access to energy in developing countries.
Yep.
And so I had a couple quick questions about this. I feel like in terms of these actual protests, I feel like they're mostly focused on reducing fossil fuel use in developed countries. And on top of that, I think countries like China have been pretty clearly, willing to fund and invest in fossil fuel extraction programs in developing countries still, and I don't think that's necessarily going to change through these protests. And secondly, I think that it's also been pretty clear that governments don't always, just because we're not spending on one thing doesn't mean we're going to spend on something else that's important. And you seem to agree that this is a problem that we're going to have to address at some point, right? And it does have certain bad effects. And so in terms of protests that are mostly just pushing for developed countries to try to reduce fossil fuel use, do you think there's any harm to that, aside from depressing young people, which I feel like at some point that's more of a personal opinion.
There are kind of micro effects and then there are global effects. At the micro level, if we were to stop burning coal, that's got a pretty small impact on economies. West Virginia would certainly have an issue. There may be good economic reasons to stop burning coal, and we're probably on the way to doing that anyway, because we're burning gas instead of coal. At the global level, it is a global emissions problem, and even if the developed world went to zero emissions tomorrow at great disruption and significant cost, it would not stop the developing world from emitting. And remember, if emissions stop, all you've done is stabilized human influences or the concentration. You haven't reduced it. So it's a pretty thin lever on which to balance things. The other, is the big movement about divestment, right, and endowments and so on. That's entirely misguided. If the Claremont colleges were to sell the fossil fuel stocks in their endowments, somebody else will just buy them. And so what good have you done?
Thanks so much.
Okay.
Please join me in thanking Dr. Koonin for joining us this evening. Thank you all for your lovely engagement with the program and for asking such amazing questions. We hope to see you all here back at the Athenaeum soon. Thank you so much. Have a great night.